distance using the Pythagorean theorem. Yesterday we had points on our coordinate grid or coordinate plane, and what we did was we created lines, we created triangles. There's actually a way that you can use the Pythagorean theorem without having to create a triangle, even if you don't have a line. And that's what we're going to work on today. So write this example down, at least have the coordinates shown. So if you have a quick little coordinate plane, coordinate graph here, you should have a point at -2 and 4, and then another point at -5, -3. Today the coordinates are really important. Yesterday, as you were going through the activity, which you all did really well with, a lot of you were coming up here and you were counting how many units were in between every point. You don't always have to do that. We can actually use the coordinates to figure out the distance. And that's what we're going to do today. So we're going to figure out the distance between this point here, -5, -3, and this point here at -2 and 4. So we're really going to find this, that line between them, how far away it is. But we're going to do it without drawing a triangle. We could have done this. This is what we looked at yesterday. We had this line in between those 2 points, and we know that we can use the Pythagorean theorem under 2 conditions. What are the conditions that I can use the Pythagorean theorem? Give me one, Michael. Has to be a right triangle, and Ezekiel, what else? We know it has to be a right triangle. What else? What do we need to know? We need to know.
You have to have 2.
You need to have 2 of the sides. Exactly. It doesn't have to necessarily be the legs, but in this situation, what we discovered yesterday, we did get the legs when we were able to draw the triangle on the coordinate graph. So what we could have done, we could have drawn the triangle and said, well, this leg is 3, and this leg is 7. So I could use the Pythagorean theorem to calculate. Now, I know I'm asking you here if there is another way to do this, but I sort of introduced the lesson that there is another way, so I'll answer that. You can find that missing side, that hypotenuse, without drawing a triangle. And some of you might want to do this. You don't have to, but you might want to. Okay? Let's skip that. Okay. If we drew the triangle, let's find our answer right now, just so when we try another method, we have the answer and we can check if we're correct. What is the length of A here? 3. Good. And the length of B?
7.
The length of B is 7. So how do we find C? So what would I plug in? What would I do?
3 squared.
3 squared
Plus 7 squared.
plus 7 squared. That's not what I want to do. Squared equals C squared. Good. And let's just finish this problem. 3 squared is 9. Good. 7 squared is 49. Good. What are they together? 58. Ooh, I forgot to get out the calculator at the beginning of the class. I'll do me a favor, just hand some out. So we can find the square root of 58. So for those of you that already have that calculator in front of you, even if you didn't have the calculator, what 2 whole numbers would the square root of 68 be between? It would be between 7 and 8. And the reason I know that, the square root of 49 is 7, and the square root of 64 is 8. And 58 is somewhere in between here. So I know it's going to be between 7 and 8. For those of you that have a calculator, you can give me a approximate, to the nearest 10th, the square root of 58 is what? 7.6. 7.6. Okay, so here we have that value, 7.6. Now, if for some reason you had to answer a Pythagorean theorem problem and you did not have a calculator, you'd still be able to do that, just like we just did. Square root of 49, square root of 64. I know that the square root of 58 should be a little bit closer here, so I would probably try 7.6, 7.7, 7.8. If I multiplied 7.6 times 7.6, I would get as close to 58 as possible. So you do have a skill set and strategy for doing this without a calculator. The concept of Pythagorean theorem, we typically use the calculator because the focus right now is utilizing that formula, not calculating the square root. So we have the answer here. We drew the triangle, we found the leg lengths, the 3 and the 7, and we were able to calculate using the Pythagorean theorem. There's another way that we could do this. Okay, we can do it without drawing a right triangle. Explain to me what I would need to find. Think about, without drawing, how you would find the numbers to utilize to still calculate the Pythagorean theorem, because that's still what we're going to do. But how could I find the values? Is there another way without drawing? How could I use the coordinates? Without drawing a triangle. I want to do this without drawing a triangle. But I still want to use the coordinates. Those are going to be really helpful. Helena, what do you think?
You're going to do the distance between the points?
What do you mean?
Drawing a line. Like from 4 to -3, that would be 7.
Okay.
And then from -2 to -5, that would be like 3.
Right. So Helena's saying without drawing the triangle, I could still visualize what this line here would have been and what this line here would have been. And some of you were doing this yesterday. As you were trying to figure out the value, you thought, well, if I drew this line, which I don't have to draw to figure this out, I'm going from a y value of 4 to a y value of -3. So what would that distance represent if I was going from a 4 down to a -3?
7.
Yeah, there has to be 7 in between them. What operation are you doing to find that? Subtraction. You're actually doing 4 minus a -3. And what is 4 minus -3? 7. What if you wanted to figure out this value, what this would have been? I'm going from an x value of a -5 to an x value of a -2. What's the distance between them?
-2 minus -5.
Yeah, you could have done a -2 minus a -5, which would have given you what answer? 3. What if you did -5 minus, stop snapping, a -2? What would you have gotten here?
-4.
Yeah, so this would have been a -3. Would the calculation have helped you, or is there something else we might need? Because the order there, it changed it, right? And in this subtraction problem, we were good because there was a 3. But then when we found the distance from the other coordinate to the -2, we found a -3. So there's a little something we can add here. So we can actually use the absolute value. And take a look at the calculation. This could be the equation that you would use. And I would love for you to write this example down. Using these 2 points, if you have -2 and 4, and -5 and -3, you should have those 2 points on your paper. What I would like for you to add is this. These 2 calculations. Because if you had another example where you were asked to do this, you could figure out where that -2 and the -5 and the 4 and the -3 came from, because they're the coordinates. So just like we did on the previous slide, and we sort of went through this already, if we needed to find the distance between the y value of 4 and the y value of -3, I could have just done 4 minus the -3, the distance between them. For the x value, I wanted to find the distance between -2 and -5 to represent that x value here, that movement on the x-axis. And I could have done -2 minus a -5. Now on this slide, which is a little different than the last slide, I have the absolute value bars. Why do you think we need that absolute value symbol? Those calculations that we just did, the 4 to the -3 and the -2 to the -5, what were we finding? What were we calculating? What about the coordinates? We were finding the distance. Good. Why do you think if we're finding distance, we would want to add in that absolute value symbol there? What do we know about absolute value? do you remember? Like if I said what is the absolute value of -7?
-7.
It's 7.
Sorry, I think about the opposite.
What about the absolute value of 8?
Whenever I
Negative
started
eight.
lines, it was using compounding the opposite.
What's the absolute value of 8?
8, that's -8.
No.
-8.
What?
It's +8
Why is it +8?
because you find the distance between that
The
number and
absolute
0.
value is actually what? When we find the absolute value, we are finding
Oh,
The distance between that number and 0.
the distance between whatever point we have, whatever value we have, and 0. Why is that always positive? Why not? Why? Because distance
The distance from it to 0
is
about
why?
1 to
How far away am I from Christian right now?
1 to 3 blocks.
3 blocks. Okay. How far away am I from Christian right now?
3 blocks.
3 blocks. Am I negative 3 blocks because I'm on this side?
No.
Why not?
Oh, that's why I use that.
Why not? If you're finding distance, what do you know?
It can't be negative.
Distance can't be negative. Right? If I go on the other side of somebody, the distance away from them isn't a negative. I'm still the same thing away. So when we do absolute values, if I'm doing absolute value and I know that that represents the distance from 0, the number -5 and +5, how far are they both away from 0? 5. They're both positive. So when we're finding this calculation here, if we're finding the distance between the two coordinates, no matter if our number ends up being negative or positive, distance can't be negative. So that absolute value symbol is helping us to represent that. Which is why on the previous slide, when we did we actually did it the other way. We did -5 minus -2, and we came up with a -3, but if we're talking about distance, it can't be negative. That's why we would have done the absolute value of that. And what's the absolute value of -3? +3. Okay. So make sure you have that example, because you're going to do an example just like it in a moment. And I'd like for you to understand why that absolute value symbol matters.
So for the next one is
If I did 4 minus a -3, what is subtracting a negative? Adding. Yep. So that would actually be 4 plus 3, which is 7. And we already know the absolute value of 7 is 7. So without drawing a triangle, I was able to figure out that the space here is 7, and the space here, which would have been my triangle, is 3. So that's when I could have done 3 squared plus 7 squared, and just like we did when we actually drew the triangle, you could have found the values. So it is the same thing, but sometimes it may be really challenging for you to draw a triangle. For example, what if one of your coordinates had a y value of like 37, and the other one had a y value of like -29? You're probably not going to have the time, nor would you want, to sit there and draw this crazy big triangle. But you could just find the distance between those 2 points, and then you'd be able to calculate. Oh, we already did that. We already did that. So I'd like for you to do this as a DOL, but you're not going to hand it in. I want you all, no, you are. You're going to hand this in. I want you to try this. Without drawing a triangle, I'd like for you to first find the distance between J and K. That would be your first one. And then second, between K and L. So that would be your second calculation. I'm going to write the coordinates of them a little bit bigger so that you can figure that out, the calculations. This J coordinate is -5, -3. This K coordinate is +1, +5. And the L coordinate is +7 and -3. After you find those two values, the actual length between them, because we're still using the Pythagorean Theorem, I just want you to write down what kind of triangle do you think this is? Is it a right triangle? This entire big triangle. Is it a right triangle? Is it an isosceles? Is it equilateral? I want you to just After you calculate, that's just a little extension. I am mostly concerned, gentlemen, stop, with these two, that you could find the value, the distance between them, using the Pythagorean theorem, not drawing a triangle. Stop. When you are done with this, you're going to put it into the DOL bin. So we'll say like 10 minutes to find these two. Okay, you have your calculators to utilize for the actual Pythagorean theorem. You have an example, and we discussed how to find the coordinates, the values, that you'll use to get your Pythagorean theorem in order. After about 10 minutes, when everybody's are in the DOL bin, we'll go over the answers, and then you're going to practice a little bit with finding distance. I'm going to pause the recording so that you can work.
I'm going to try to find my line.